All right, perfect. So in this section, we're going to be looking at the support for shared access signatures as we're connecting to Relay in Azure. And so that's going to apply to a few of our adapters on the send side, or basically on the client side where we're consuming relays, and some of our adapters as we're actually hosting services within BizTalk Server, and we want to expose those out to the cloud so that clients from wherever they need to connect from can actually connect into our on-premises systems without having to worry about a bunch of firewall configuration. So we'll be looking at that here. And basically, if we're looking at where that's applied, we actually have support for shared access signatures on our basic HTTP relay adapter, our NetTCP relay adapter, both of those for hosting services. So if I wanted to have a receive location in BizTalk that's actually accessible through the cloud, I can actually select those two adapters, either one of those to expose either a relay that's just doing traditional SOAP-style communication at an HTTP endpoint in the cloud versus a NetTCP relay, which is going to use, obviously, that style of communication there. Now, on the client side, I can use the basic HTTP adapter to connect to one of those relays, and I'll have the ability to use shared access signatures for authentication with those relays that are hosted out there, as well as the web HTTP adapter. So if there's a RESTful service that has a relay endpoint, I want to be able to send that kind of token, I can do that there. So why is this a big deal? Why is this a thing that I care about as I'm looking at this new features list? Oh, it's just another type of authentication, not really a big deal, right? Well, I actually looked back because it's been some time since I've been working with Azure. I actually started in that space back in 2008, October 2008, right as was announced at PDC. Got in and kind of started checking out everything there. And one of the services that was around even back then was the Access Control Service, which was a service that did great things. And in fact, I went through the old documentation. I pulled this diagram out just to show some of the cool things it could do, but also as you look at that and you take a step back with kind of a critical eye, you realize the complexity there. So what was ACS providing us in the past? It was giving us identity federation. And that was fantastic. If I had a trusted authentication provider, I wanted to be able to authenticate using credentials from that, map those to claims internally. That was a great solution for that kind of problem. But oftentimes, if I was wanting to do something simple like host a relay, have an on-premises relay that exposes an endpoint to the cloud, I wasn't wanting to necessarily take on all that complexity. And so oftentimes we kind of reduce that to using a shared secret at the end of the day. And so what our SAS signatures are going to do is rather than provide a federated identity solution, they're trying to provide a way to delegate authority in a fine-grained fashion. And make it so that if we just have a set of resources we need to provide access to, we can sign a token and give it to a client with an expiration date, and they can just use that token to call and have access to only what we want them to have access to. And in this case, it would be a service bus namespace so that we can actually, within that namespace, listen at an endpoint and host a relay there. And so if we look at the more current documentation, in fact, this one was just from a few days ago, you'll notice that anywhere where it's talking about authentication, authorization with service bus or relay, you see that there's a call out there that shared access signatures are recommended over ACS. Now, it's not to say that one is better than another. They're trying to solve slightly different problems, but one is going to be slightly better for this situation. And so SAS authentication is going to be our preferred option. Now, before BizTalk Server 2016, we could host relays. That was still possible, but we couldn't actually authenticate with that with a SAS token. We were using ACS, which means there's another resource in Azure that we'd be submitting information to. There was network communication involved with that authentication beyond just the initial send of the message. So nice, simplistic model, but still powerful model is now possible with 2016. So how do I set that up and where do I use that? Well, if I have a endpoint within BizTalk Server that I want to expose out to the cloud, I can set up a receive location for that endpoint that's using the WCF basic HTTP relay or NetTCP relay adapter. In the security tab for that adapter transport properties, what I'm going to find is that there's a section at the bottom where I can select to use shared access signature authentication with service bus. If I select that and I say I want to edit the details for that, I do have to provide a shared access key name and key. And what's going to happen is when it goes out to actually host the relay, it's going to use that information to sign for itself its own little message that says, I have access to these things. That can present that to Service Bus to be able to, or to Azure Relay, I should say, to be able to host that. Now that key is actually going to be one that has to have access to the whole namespace, because that relay doesn't exist until that endpoint is enabled, until that, in this case, the receive location is enabled. So it actually goes out and sets it up at that moment. And so it actually needs managed level access to the entire namespace to be able to say, within this namespace, I want to provision this endpoint. And so you'll find in this case, in the screenshot on the left, that we have a picture of the shared access policies configuration for the namespace that hosts that relay. And we're going to pull the key from there. Of course, you can steal that key all you want, because that's not the key anymore. I promise. Maybe it is. We'll find out. All right, so with that set up, the other thing I can do is I can say that when clients call into this, maybe they don't need to provide credentials. Maybe they have this endpoint in the cloud that they can call anonymously. Anyone can send data to that. Maybe that's kind of crazy, and I don't want to do that. Maybe I want to actually require that they also authenticate themselves. And so on that same security tab, I can say, you know what, I want to make sure that my clients, when they're calling in, they have an access token as well. And so maybe at that point, I would have something like a send claim that they're able to use, as opposed to fully manage everything there. They can send messages to the relay, but maybe they're not able to manage that. So I can actually give those credentials out, or I could actually provide a way for them to get those tokens. Now at that point, as far as generating the client token to be able to authenticate with that relay, that can be done without additional network communication as long as I have that key. And so we have a nice little C# snippet just to show that as long as I have the Service Bus SDK added as a NuGet package reference, I could do something like this to actually use the client key here with the nice super secret value to say that for a certain namespace they have the ability, in this case, to send a message out to that relay. And that's going to give me a nice string formed token here. And where that gets used is, if we wanted to look at that client communication at that point, is it might look something like this. So they'd be posting out to some endpoint in the cloud. So notice the host here is at servicebus.windows.net, and they're going to pass in not an authorization header, but a service bus authorization header that provides that shared access signature. And you'll notice that within that, it's going to list out the resource that they have access to. It says basically the client is declaring that they have access to that resource, and then it's going to be signed using that key. So it's saying, here's the resource I can access, here's the key. It's also going to have an expiration for that, so it says I'm allowed to access that resource until this time, and that's what, that whole idea is signed in there. And then they can send that alongside their message. In this case, for our basic HTTP relay, that's going to be a SOAP message, so you'll notice we also have the SOAP action header to say what they're trying to do, and we actually have the message payload here, which in this case, they are passing basically a string wrapped as a XML message that's overall wrapped in a SOAP envelope. So a lot of overhead there just to send a string at the end of the day for that one, but we can deal with that here in a moment. All right, so that's what it would look like to call from the client side. Now at this point, what we have is we have BizTalk Server able to host endpoints in the cloud secured using SaaS tokens. And that's a beautiful thing. We can have an endpoint out there that anyone can access. We don't have to do crazy amounts of configuration in terms of firewalls, and that's a happy story, and we could end it there. But at the end of the day, if we look at that adapter and how that's hosted compared to other WCF adapters, it's not an isolated adapter, which means it's not running within the context of IIS. So if I was doing additional processing within the IIS request pipeline to do things like rate limiting or do things like additional controls of who's able to call or even caching, that's not going to be something I have with this in-process adapter. So it's basically just going to be anyone that sends data that has access to reach that endpoint, it goes to BizTalk, and BizTalk does 100% of the processing of that message. Now, if that's what I desire, that's great. But maybe I want to take advantage of some of that same kinds of functionality I would have had if I was using an isolated adapter, where I could actually hook into that pipeline before BizTalk processing and do additional work. So I was kind of looking at that, and from the cloud perspective, there's actually some nice services in Azure for that as well. So we could actually have that relay potentially called by something like API management. So API management, in a sense, is the client calling into our relay, but then that allows other clients to call it, and as it's doing that, it can do any processing we'd like. So it kind of has its own little pipeline processing for each request, and we call those policies as we're setting up those pipelines. But we could do things like translate from a JSON message, so our clients basically see that service as a just a standard RESTful service, to a SOAP message before we actually send it to the relay. Our relay is still secured with a key and token that basically only API management would know at that point. API management can layer on things like caching. It could do things like rate limiting, and it can even allow multiple users to have different levels of access in terms of the ability to send more requests in different subscription levels there. It also provides a nice portal for us. So if we wanted a larger picture where we have a BizTalk hosted service at the end of the day that's exposed through the cloud but also has additional processing around caching and additional authorization and rate limiting and throttling and all that fun stuff there, we have it. We have all the tools that we need without having to reach too far outside of BizTalk and outside of Azure. So I can put that slide up and it looks really pretty, but does it work and is it real? Can I do all of those fun things using these different tools? Well, I want to show that you can, and I want to show how that is set up and what that looks like. So I'm going to come out here to a virtual machine that I have running over on a server on the other side of the wall. It's definitely not exposed to the larger internet. It is basically an on-premises machine behind the firewall and otherwise not accessible externally. At the moment, I have a receive location set up, which is basically doing a fun little pipeline that just takes in a message and sends it back to the caller. I have a nice map on that port that's going to be translating the message and appending the timestamp for when the message was processed so that we can actually see, if we have caching enabled, for example, that that message had been processed in the past and we're seeing a cached response. So at this point, what I'd like to do is I'm going to configure the actual adapter properties for the WCF basic HTTP relay. And we'll notice on the security tab that we have both the shared access signature enabled for authenticating with the relay to say that we want to be able to set that up. And we're requiring that our clients also pass in that service bus authorization header with the token so that they can actually call into it. So we're not just allowing any old client. So we have both of those settings enabled. Now until I enable this receive location, what I'll find is that the actual endpoint itself doesn't exist. So if I look at my WCF relays for my namespace that I have that set up for, there's nothing out there. The service isn't in existence at the moment. Whenever I enable that adapter, or enable the receive location rather, the adapter actually talks to Azure Relay and it says I have this WCF endpoint I'd like to host, and if I refresh this page, we'll find that that is now lit up. That is a real address that people could actually hit and use if and only if, let me get to the relay settings there, if and only if they actually have the token for that. So we'll notice that we have this service out here, happily named service, and there's one listener, which is my BizTalk Server instance. All right, so that's great. It's a dynamic relay, so we're, again, authorizing at the namespace level, not at the relay level here. So if I want to layer in front of that something like API management, what I could do is I could define the shape of my API within an API management service here, which I've called BizTalk 2016. I could define the operations that I'd like to support. In this case, I have a get message operation, and I can define what I want those requests to look like. And then I can combine input or inbound processing policies and outbound processing policies to translate, transform, apply rate limiting, caching, all that fun stuff. And in this case, what I'm doing is I'm actually setting the service bus authorization header on the inbound. So I'm adding to the message the token we would need to actually access the relay. So the client doesn't know the token. We're applying that here. I'm saying that I want to be able to look up from cache. I'm doing things like changing from get to post. I'm adding the SOAP action header. And I'm actually replacing the body of the message with, because there is no body for a GET request, placing the body of the message with a SOAP envelope, and I'm taking the inputs from the query string and actually putting that into the message using policy expressions. So I'm actually building up a SOAP message that we can send in from what kind of looks like a RESTful service. So that's kind of fun. And just to prove that this is real and out there and we can call it, what I'm going to do is I'm going to go outside of that virtual machine, make sure that that was enabled. Let me refresh, make sure it's all happy still, so it is. And I'm going to come out to this laptop. And this is actually Rob's laptop. I'm stealing that from him temporarily. And I'm going to grab this address. Now this address is basically the developer portal. It's something that we would give to consumers of this service so that they can discover this service, so they can discover the operations that it supplies. And so we'll notice that from here, I can look at the APIs. I'll notice that one of the APIs published out by QuickLearn Training, and the only one, is the BizTalk Loopback API, which has our lovely request URL here. And I can actually try it, and I can submit a message to be processed by BizTalk Server 2016 via relay. So I can submit a message, and whenever I send that, it goes into API management, gets sent to the relay, and of course BizTalk is on the receiving end of it, and it receives and processes that message. And because it hasn't been sent in a while and I just kind of started everything up, it took a long time. It took about 927 milliseconds. Now notice the timestamp on that, 11/22/21. If I click send again, it takes a little bit less time, and actually that wasn't within the time period for the cache. So let me actually send that a few more times. You'll notice that it stays constant, 11/22/42, 9 millisecond response time, and then it switches over to the cache is invalid again, and we'll be able to see quick responses while the cache is still warm, and then longer responses as it falls out of cache again. So that's allowing us to intercept that message before it gets to BizTalk, figure out if we have a response, so that BizTalk only does the processing it needs to do, accesses the systems that it needs to, and then we can actually have API management going in there doing the caching. But overall, API management here is just being a client for our relay. It's using SaaS authentication just like BizTalk is using that now that we have that in 2016. So with that, that's what I have to show you here with the SaaS authentication support, or the shared access signature authentication support. You have to be careful with saying SaaS because there's a lot of things that overlap with SaaS, as you say it. There's
SAS, I think
exactly
that's a better way to say it.
Software as a service. So, all right. So with that, that is my section here. I want to open the floor for any questions that are out there. I know that Rob and Matt have been monitoring for that. So
we have no questions.
No questions.
So far.
All right, no worries.
So we can give people a few seconds.
Yeah.
But I don't know. I did have one question.
Sure. What's up?
Since give people opportunity to ask something. How long did it take you to set all that up, Nick? Because we're just seeing the end result.
Well, for sure.
Like that's like a week of your life, right?
Yeah, no. No, so the BizTalk side, obviously the communication, the adapter settings, that's really quick. I mean, that's minutes to set that up. Figuring out what I wanted the message to be and what I actually wanted to show there, that took a while, but actually setting that up was I don't know, like probably less than an hour to build out the pipeline and to set up the message and make that do what I wanted it to do. My longer time investment there was on the API management side of setting up the policies to do what I wanted to do, and that was a bit of an experimentation to figure out what I wanted. But I can include some of those details when I do the write-up of this, so happy to talk about all the little snags and fun things that we encountered along the way.
Okay. So it looks like we've got a couple of questions here. So can the relay type be HTTPS?
So that is an excellent question, and actually it is in this case. So if we look at how that's being exposed, it is exposed via HTTPS by default. So,
so I guess maybe the question might be, can it not be HTTPS? because it is HTTPS by default. But.
All right. So yeah, in Azure it also shows up as HTTPS. So as I'm making the call, you'll notice in the back end where API management is actually sending that through, it is reaching an HTTPS endpoint there.
I think you might be asking about the API management front end.
Right, so the API management front end, let's see, do we still have that tab open over here? I think I closed it.
Yeah.
You can actually see the full request on this side, so you'll notice that even there, the API management front end is HTTPS. So it's HTTPS all the way through.
All the way through.
Another one, this is a general question. Will the PowerPoint be available after the call? I believe so. Yeah, so we're going to be packaging together all the resources.
The PowerPoint and recording of the whole webinar will be available later.
Any concerns around throughput or latency? If it was concerning, if I'm looking at the numbers and it's not what I want it to be, obviously yes. And there's different places we can optimize that, right? So that we could look at, is it processing within BizTalk that I need to optimize? Is it my own network connection out to the internet? Maybe we want to look into express route, at which point service bus relay, I don't know. Maybe at that point we change up how we're going to be setting everything up. But anyway, It could be that. We could look at what we're actually chaining together. We could look at more aggressive caching, more aggressive rate limiting, but as far as concerns around throughput or latency, if there are concerns, then address them. But personally, I'm happy with that response time for my little sample message that I don't care about. So I guess it depends. But probably, yes, we would always want to look for that.
It feels like a really hard question because there's so many different factors and variables playing here.
Yeah, for sure.
But once we found that problem, then we got to isolate the bottleneck and try to figure out how to alleviate those.
Yeah, so I guess it would depend on the scenario, how important the message is, what the non-functional requirements are as far as response times that we need to be able to honor and things like that. For this one where it's kind of a trivial message, less than a second seems happy to me, especially given that it is going out over the internet and my client is also calling out over the internet. If it was within the same organization, application to application within my enterprise, and I was seeing latency is that high, I would be a little bit concerned. But if it's, at this point, some external organization to my organization over the internet, already there's going to be an understanding that there is some latency there. So that's the kind of scenario that this would be designed for anyways, a place where we do have that external communication need.